my YouTube channel, and this video is about designing a scalable system. So if you are new in this system design, so this is correct video for you. Okay, so we will be seeing how one can start designing a system. If you don't have any idea about system design, it's okay, this is the perfect video for you. Okay, let's get started. uh, I want to tell you a rule. It is a very basic rule of designing any software. The rule is never do over engineering. Okay, so if you are given a problem, just try to solve that problem and then tackle each and every issues which you get one by one. On day one, no one is going to design a system which can handle billions of traffic. Okay, so we will be doing starting our system design from scratch. Okay, let's suppose there you want to build a software. For now there's only one or two requests per second, uh, or only one user is using that your software. Okay, so we'll design like that from start. Let's suppose this is what you have built. This is a user and this is one server. Inside the server you have your application code plus your DB. Okay, so this is good if only one user is using the software, and also that also for very few purposes. So this is good, but the issue will come when there are multiple users using a software. Also, if there are more than one request per second, is this server handle your request? No, this will not be able to handle your request, because at a time it can only handle one request. But there are multiple requests coming parallelly, it will fail, or the second request will wait, and like this there will be waits for more coming requests. So what we can do here is we can clone this thing and create two servers. Okay, now while cloning, what we have achieved here is, if there is a user who is hitting one request and this server is processing that request, and at the same time the same user comes and hits another request. Okay, so the second server can take that load and handle the second request, and like this we can add multiple servers. But again, this is good for a single user who is using a software. But what about multiple users? Okay, and also you'll see that in this server we have our application code plus a database. So let's suppose for user who is accessing through this server, if he's doing some update in our DB, it will be in this server only. And if he want to fetch that record he is updated, and if the request come to this server, he will not be able to fetch because this DB doesn't have that data. So what we can do here is we can build something like this. We can add a load balancer here. So what this load balancer will do, it is itself a system which will decide which user's request is has to go where. Okay, like we can do some kind of hashing on user ID and say, like, if user 1 is coming, you will go to this server only. User 2 is coming, you will go to this only. Okay, so now this problem is solved by adding a load balancer. Don't worry, I'll create another video of how load balancer internally works. It is also a very nice problem to solve. We'll solve it again in another video. Okay, so we can see, and also there's one problem. Like, if we want to scale further, every time we need to increase number of databases also. What if 1 DB is alone to handle all the data of this application needs? Okay, we are replicating database also every time when we are adding a server. So what here we'll do is we will just remove that database from our server. This we will have another server for DB and another server for our application code. Okay, Like this, we are able to solve two problems. First is we can independently scale our system. Like if we want more servers, we can keep on adding the servers. Plus, if we want to scale a database, we can do it separately. So it is not dependent on each other now. Okay. And second, let's suppose for user 1, there were 100 requests, and for user 2, it was only one request. So for user 2, this server was handling, second server was handling, but for user 1, this was handling the request. Now what our load balancer will do, it will only always send for user request coming to user 1 to a server 1. So this server is overutilized and this is underutilized. So this is a bad approach, and this is a bad approach of balancing a load also. So what we can do here is we can do round robin thing, like any request comes to go on for server 1 first, then on server 2, then again on 1, 2, or we can do something like which has the least number of requests handling, that server can take the new request. Like this, the load is also evenly divided, and you have a database which can handle the load separately. So both app servers have access to same DB. Okay, but is this the final approach? What about number of requests start increasing? So we'll obviously duplicate this server. Okay, but since this server is now out of the since the database server is out of the application server, so there will be always a latency here to fetch data from DB. Okay, and this database will also fetch data from the disk. Okay, so it will also be always be a bottleneck for frequent access data. Like if you want to see some static data which we have in a DB, or some that data which is rarely gets updated. So in that case, hitting database every time is not a good approach. Okay, what we can do is what we can do is in this application code itself, we can call that like let's suppose there is you are creating any you are fetching user details for any software. So user detail is something which is not changed that frequently, like username, user email ID, or user phone number. So this application can save that user detail inside its memory only, and can access that user details whenever it wants. But what about if this server is keeping that details inside it, but second request come to server 2, it will again hit the database. So this caching mechanism will not work here for growing softwares, because there can be n number of servers, not only two. So what else we can do is we can add a cache layer, and this is a distributed cache which can be accessed by both of the servers, application code servers. Okay, so how will our application code work here? First of all, if we want to see if there is any data for a user, it will get it from cache. If it is not there in cache, it will call database, fetch it here, and then save inside this cache. Also, it is this server has to do more work what it was required, but it is helpful for this second server. Now if requests come for same user in this second server, when it will see cache, it will always get that data. But now you'll say that what about if someone updates their user details? So what we can do is always have time to live in this cache. Like we can say for 10 minutes this data won't be deleted. So after 10 minutes it will be deleted automatically by this cache. And how this cache is so fast? How it is able to get data fast? Because what we are doing here, we were doing earlier with DB also. Okay, we were hitting another server. So what this cache does is it saves data inside its memory, not in the disk. So this is not persistent. Okay, so we cannot use this cache as a persistent database. Also, this data, its latency is less because we are fetching data always from memory. Okay, so this is what will help us to grow our system if number of requests keep on increasing. Now see, what was the earlier system? This was the first design which we came up. Then we started seeing the problems and solving one by one. And that also when the number of requests started increasing. If you have tried to solve the problem on day one, you will never be able to do it. You cannot design the fully scalable system on day one. Okay, so it always goes step by step when the load increases. Now again, then inside this server now there's few things which requires a lot of time to get processed. For example, I want to send some notification. Okay, this user want to send some notification. It says, hey, my application code, I want to send some notification, please do that for me. So this application code, since this application code is not for sending notifications, it will obviously have some third party softwares or some third party service it will use to send that notification. So it will hit that request, and also it may take some time to process a notification because we have to build the payload, then hit another service, and we are not sure how much time that service will take. So on this for this user, we cannot show the loading screen for that particular period of time. It can take maybe 5 minutes because the third party service can had much. There can be a time where third party service which we are using for sending notifications have high traffic, so it is not able to send notification quickly or in real time. So what do we do here? So if we want to do like say notification, something which can be done in the background. Like if I say a application, he sent this notification and he says, yeah, your notification is sent. And in the background, if that application is processing my notification, I as a user is okay. Okay, so what we can do here is we can try to use this queue mechanism. So what I'll say that whenever this user say, hey, send one notification to our application server, this application server will say, will validate the request. If it is a valid request, it will push one message inside this queue. Okay, as soon as this message is pushed inside this queue, now we can say that there will be another server, which is a consumer server, will listens all the messages inside this queue, and it picks one message at a time and process that in the background. And if sending some notification is taking 5 minutes also, we are completely fine because it is done in the background. We don't have to care. The notification will eventually come. Okay, I will create a in-depth video of different type of queues which we can use and why we are using it, more detailed analysis, and where this queue saves the messages, how this consumer pick that message, how to scale a queue. Maybe there can be 1 million requests at a time in this queue. Then what will happen? Okay, so I'll create another video explaining how this queuing system works. Now, we have now fully scaled our application server, but what about our database? Like there can be this application code may be updating some data in this database, and what about if there we have heavy reads for that data? Like if one user is updating some details in this DB, and these two users are trying to fetch the same details, and maybe 10 users at a time is trying to fetch same details. So we can see that our read is more than write. What we can do in that case? Okay, so what we can do here is we can come up with a master slave architecture of database. What this master slave architecture is, whenever we want to write something, we will make connection with this master database, and as soon as we have written something in the database, it will eventually do asynchronous saving the updated data in a slave DB. Okay, and when we want to read something, we that application can that API can connect our slave database and try to read data from there. Now, what this will help us is like our read and write are separately. We have separated. Now, if we want to scale, we can scale this slave one by one. We can add multiple slaves here. Okay, and that is completely fine. One drawback here is maybe after updating our data, it can take a little bit of time to update that data in slave. So till that time, you'll get old data, but that is completely fine. If we are not dealing with that consistent data, if we are running heavy queries, okay, so we are okay. But if we want to deal with that data which is very we want to get the updated every time, like for example, if we are dealing with money, like if we want to see what is the updated amount or if the transaction is completed or not, we can create connection with master and hit one query, but we have to make sure that query is not heavy, which is not locking our database. Okay, so master database should not do heavy read. If we want to do heavy reads, we can always take help of slave database. Okay, so now we have also so there are many more ways to this scale our database. Like if we want to scale a cache also, so this is not so cache is done by master. For scaling cache, we can do master to master pattern here. We can use that pattern. I'll create a separate video how to scale a database. There are multiple ways apart from master slave. Also, we can do data partitioning, data archival. So there are many other ways. I'll create another video of where I'll explain in depth of how to scale a database, both SQL and NoSQL. This cache, by the way, is a NoSQL DB. We usually use Redis here. It is a key value pair which saves a value based on a particular key. Like if we want to fetch user data, our key will be user ID, and based on this user ID, we'll get an object where we'll have all the user data, like that. But let's suppose this is done. If you want to serve one country like India, this system is completely fine, completely capable of handling that much traffic. But let go beyond that. What about we want to scale our business abroad also? There can be multiple countries working in different time zones. Uh, okay, so what will it work there? No. First of all, our our scale will increase. So obviously, we have to increase the servers also. And do we can we give a different behavior for someone sitting in USA, their database, and someone sitting in India? Do we need can we keep their database separate, their servers separate, and scale them separately? Yes, we can. Now comes the concept of data centers. So what this data center is? So let's suppose there are multiple data centers we can create inside a country. Like for India, this is a data center where it had itself in a deep database here. There, its consumers queues are different in different data centers, and for USA, the data center is different. So our load balancer will take care of distributing data from where the request is coming. If the request is coming from India, it will the closest data center is India. It will transfer data it will transfer request to India's data center. Similarly for different countries. So now one drawback here is so person sitting in India cannot access the data in US. Like currently I'm sitting in India, I'm using my application, I'm able to do everything in my application. But what about if I go to US? Will I be able to see the same data of mine? Will I be able to do all the same work? No, because there is no connection between our data centers. So here what else we can do is we can do some asynchronous syncing of data also in our DB, so that our database are also kept updated. Okay, so that if users go to another close to another data center, then also it can he can use their application the same way he was using earlier. Okay, so this is the concept of data centers. Now there are multiple things like static data which we have for our websites, like a logo is something which will never change, and it is a static data. So whenever we load our website here in this for this user inside his laptop, do we need to hit load balancer and then application layer and then bring that image from there and then show it here? Is it really required? I don't think so, because it is static data. So since we were doing some kind of caching here when we were hitting the database, what about if we do some kind of caching here before hitting any server? Yeah, this is what is called CDN. CDN is used to cache static data. So CDN also works on data centers, how data centers work. So for a user, uh, whichever is the closest CDN, it will fetch data from there. If that closest CDN doesn't have that data, this CDN will now say that who's my next closest CDN. Okay, so he will try to fetch data from there. If no CDNs has that data, then only it will go to application code. Okay, so this CDN help us to uh, do caching of static data only. I will create a separate video explaining how CDN internally works and when we can use and when not. Okay, so just an overview about CDN is that it helps you cache the static data. I think, yeah, we have created our system here, and this can handle billions of requests. So if you see what we've started creating and now what we have created, we started with this server, only one server for one user. That was perfectly fine for the period of time where there was only one user which doesn't have that much use of our software. But now, since much users increases, the use cases also increases, so we have now scaled our system much more. Okay, so I think I have covered all the topics which is required to for scaling a software. I will be creating many videos of small things like how queues work, how consumers work, how we can scale database, how to archive. There's many interesting topics I'll be discussing with you all. Like for example, in Gmail, when you enter your username, you see that Gmail can tell you that username exists or not within no time. How Gmail is able to do that? Obviously not. He's not not searching an entire DB for entire. So many people of different data centers are saving creating their username in Gmail. So obviously, Gmail is not searching in database. So how they are able to do that? How Amazon is able to show you for orders or which you have ordered in 2019, 18? How Amazon is able to do that? How these you are able to see your mutual friend in Facebook? So these small things I'll be creating video and letting you know what the architecture really looks like. So yeah, stay tuned with me, and all the best. Let me know how you like this. Let me know did you like this video or not, and do comment if you want any video on specific topic. I will prioritize that. Thank you so much.